Welcome to the Explainer. So we've got to build a whole new electricity grid for our net zero future, and it's going to cost a fortune. But what if I told you the smartest way to save billions wasn't with more steel and wire, but with a simple change to the rules? Let's get into it. Okay, so first, let's just appreciate the scale of this challenge. The people who actually run the grid have a name for it, a Herculean effort. They're basically saying this is so massive, it's pushing the very limits of what's even possible to achieve.
And this isn't just about it being difficult, it's about the staggering cost. To pull this off, we need to spend 4 times as much as we have over the entire last decade combined. That's a huge amount of money, and ultimately, it's all of us who will be footing that bill.
So how can we make this Herculean task, well, a little less Herculean? In this explainer, we're going to follow a really fascinating economic argument. We'll start with how power is priced, uncover a pretty surprising paradox, meet a new game-changing technology, and see how it all leads to a powerful conclusion about using smarter rules to get lower costs. So where do we start? We start with the basic rules of the road for our electricity grid. You see, it turns out there are 2 main ways to price power. And the difference between them, well, that's the key to this whole story. Let's think of the grid like a giant highway system. Right now, we use national pricing. It's like having one flat toll for the entire country, no matter where you are. It completely ignores traffic jams. So when gridlock, what they call congestion, happens, the grid operator has to pay a bunch of extra money to sort it out, and that cost gets passed right on to us. Zonal pricing is different. It's smarter. It's like having variable tolls that are higher on the busiest roads. The price actually changes by region, reflecting the real-world traffic. The price itself becomes a tool to manage the grid. And here's a perfect picture of what that looks like. In our simplified Great Britain, you've got tons of cheap wind power being generated up in the north, so the price there is low, let's say £10. But down in the south, where demand is high, the price is way higher, maybe £50. That price difference is a super clear signal, right? It's screaming. There's a traffic jam on the power lines connecting us. Now, our current national system basically just pretends that traffic jam doesn't exist. It creates one single imaginary price for the whole country, say £30. But here's the problem. The grid physically can't get all that cheap northern power to the south, so the operator has to pay extra to turn down the cheap power up north and turn on expensive power down south just to keep the lights on. That extra cash? Yeah, those are the constraint costs, and they go straight onto our bills. Okay, so we have 2 different systems. And this is where things get really interesting, especially when you think about the most obvious solution to a traffic jam. Just build a bigger road, right? Build more power lines. In our smart zonal world, if we build more wires, add a new lane to our highway, we can move more of that cheap northern power down south. And look, the price in the north goes up a little, the price in the south comes down a lot, and that gap between them gets smaller. It's really easy to calculate the economic value that new power line just created. Now, in the national system, that new lane doesn't change the single £30 price tag. But what it does do is shrink the traffic jam. That means the grid operator spends less money on those annoying extra constraint costs. So the benefit here is just a reduction in those wasteful payments. And here is the paradox. Get this. If you actually do the math and calculate the total economic benefit of that new power line, it turns out to be exactly the same under both systems. The value is identical. In this simple, closed world, both methods agree on exactly how much that new highway lane is worth. So that begs a pretty big question, right? If both systems come to the same answer about the value of building more wires, what's the big deal? Why are we even talking about this? What's the problem? Well, the problem is that our simple model left something really important out. There's a new kind of player on the modern grid that completely changes the game. Meet the two-way assets. Think of giant grid-scale batteries or the huge underwater cables called interconnectors that link our grid to other countries. The key thing about them is, unlike a traditional power plant, they can either supply power to the grid or draw power from it. They can be a power station 1 minute and a massive customer the next. And how they think is incredibly simple and rational. It's all about the money. They look at the wholesale price of electricity. If the price is low, they'll buy power, like charging a battery. If the price is high, they'll sell it. Their entire operation is based on one thing, the price signal they see. So this is it. This is the crucial point where everything comes together. How do these super smart, financially driven assets react to the very different price signals sent by our 2 systems? Because wow, does it make a difference.
All right, picture this. An interconnector sitting in the south of England, under the national price. It sees the single, artificially low national price of, let's say, £35. Meanwhile, the price in France is 40. So what does it do? The logical thing. It starts exporting our power to make a quick buck. But here's the thing. It's doing this in a part of the country that's already short on power. It's literally making the traffic jam worse.
But now, let's flip the switch to a zonal price. That same interconnector in the same place sees the real local price in the south, which is high, say £45, because power is scarce there. The price in France is still 40. Now the smart money is on importing cheap power into Great Britain. See what just happened? By getting the correct price signal, the interconnector automatically starts to help solve the very problem we're trying to fix. And look, this isn't some rare theoretical event. This chart shows it's happening all the time. For some of our biggest interconnectors, the price signal we send is so wrong that the power would be flowing in the completely opposite direction for up to a quarter of the entire year. They're constantly being told to do the wrong thing. And those wrong decisions come with a staggering price tag. Because the national system encourages these interconnectors to make congestion worse, the grid operator then has to scramble and pay a fortune in real time to fix the problem. The estimated cost for just these 5 interconnectors is up to £830 million a year. Okay, so let's pull all these threads together. Let's bring this home and figure out what this all means for that Herculean effort we talked about at the very beginning. After this whole journey through the economics of the grid, what's the one big idea you should walk away with? It's actually pretty simple when you lay it all out. The national pricing system we have now, it sends out the wrong information. It makes our grid's traffic jams look much bigger and more expensive than they really are. This, in turn, makes it look like we need to build more and more expensive power lines. Zonal pricing does the exact opposite. It sends the right signals, so these smart assets automatically help solve the problem for us. This reduces how many new wires we think we need to build, and it saves all of us consumers billions. And that leaves us with one heck of a final thought. That Herculean effort to build the grid is very real, but a big chunk of the problem might just be self-inflicted. So before we spend tens of billions of pounds pouring concrete and stringing wires across the countryside, isn't it possible that the smartest, cheapest, and fastest first step is to simply change the rules of the road?